Okay, using what we've learned about rational functions here, which graph below would match this 3x plus 9 over 2x plus 8? So let's see. We learned that when the degree on top and the degree on the bottom are the same, that the horizontal asymptote will be from there because the x's basically like cancel, reduce, simplify, divide out. So which one has a horizontal asymptote at a positive 3/2, or possibly? The only one that I would eliminate so far would be this one. I think the other three all look like they're up there. Now, what about the vertical asymptote? The vertical asymptote comes from the denominator. Nothing, no factors cancel. So when does 2x plus 8, this was the horizontal asymptote. There's now the vertical. So when does this equal 0? Subtracting 8, negative 8, divided by the 2, negative 4. So my vertical asymptote's at negative 4. Well, that looks like negative 4. This is a positive 4, so that's out, and that's negative 4. So now what's the difference between graph A and graph D in looking at them is just the location of the graph. Is it in the lower right and the upper left, or is it the upper right and the lower left? So one way to determine that is, what's my x-intercept? Because notice this one has an x-intercept here to the right of that negative 4, so like negative 3. This one would be to the left of the negative 4, so like negative 5. So when does 3x plus 9 equal 0? Because that's like my y is 0. That's an x-intercept. When y is 0, you're on the x-axis. Subtract the 3, or sorry, solving the problem in my head already. Subtract the 9, divide by this 3. So which one had the x-intercept at negative 3? I would suggest that was this one right here. So the correct answer for the graph would be D. Putting all those pieces together for rational functions, asymptotes, intercepts, if anything were to cancel out, we would have these things called holes. But 4.2.22.